Hello everyone, welcome to the kinematics and dynamics of machinery class. In this video I'm gonna discuss the cam profile and I'm gonna show you how we can extract or generate the cam profile graphically for a given displacement diagram of the follower. So this is like a normal extension of the thing that we already covered in the previous video. In the previous video I showed you how we can generate the displacement diagram of the follower and we said that the follower would exhibit different types of displacement like simple harmonic motion, circular motion, parabolic motion, and so on. So we discussed how we can generate these different forms and different types of the follower motion over the previous videos. In this video, I'm going to show you how we can, starting from the displacement diagram, how we can extract the cam profile or the cam shape that is needed to give or to provide the displacement, the follower motion as already described through the displacement diagram. So this means that to generate the cam profile for a given displacement follower, of the follower, the displacement diagram should be first generated. So we have to generate the displacement diagram first, or at least it should be given to us. Then we can extract or generate the cam profile. And this is what we're going to do through this video. So before we move on, let us fix some points regarding the cam nomenclature here, like these different geometries of the cam. So and let us understand these different geometries and different things regarding the cam, starting with the trace point. So the trace point, it should be a point that belongs to the follower and the pitch curve over the cam. So what is the cam profile? If this red curve that I highlighted here, this is the cam profile that we would like to come up with. This is our main output. This is the what is required from us for this type of problem is just to come up or find this cam profile. But there is other different things that we have to consider in addition to this cam profile, like the pitch curve. So the pitch curve, which is this green highlighted, as you can see, the pitch curve, it is very similar, it is very parallel to the original cam profile, but it is offset. It is just shifted with a certain distance. This is in case that we're already using a roller follower. As we discussed before, we have different forms and different types of the followers. What the two types of the follower that we're going to consider with this plate cam mechanism, which is the either roller follower, like this case, like at the end of the follower, at the tip of the follower, we're going to fix a roller, or we're going to use the knife follower, and in this case there is no roller for such a case. But in case that we are using a roller follower, the pitch curve and the cam profile, they will be two different profiles, and there should be an offset distance between them, and this offset distance, as you can see, it should equal to the radius of the roller. Make sense? This is in case that we are using roller follower. But in case that we are using a knife follower, it means that we just remove the roller. So definitely the pitch curve and the cam profile both will be considered together. Make sense? So what is the trace point that we're already writing a definition for it here? This is the trace point that I'm talking about. It is a point, it is a common point between the follower in addition to the pitch circle or the pitch curve. And at this point, this trace point, as it moves or rotates over the cam profile, it should describe or give us the pitch curve, right? So this is the trace point. It is again the point that belong to the follower and the pitch curve of the cam. This point is what defines the follower displacement in correspondence to the cam profile. So as we give rotation to the cam, this trace point, this is the point that it should be traced over the displacement diagram of the follower. You could consider that this pitch curve, if we expanded it, if we expanded the pitch curve, this should give us the exact displacement diagram of the follower that we already considered before. Makes sense? So this trace point, this is the essential point that it should be traced over both. The cam profile also should trace the displacement diagram of the follower. Make sense? So since we are talking about the pitch curve which should be the green curve, this green curve, which is very parallel, as we mentioned, to the cam profile, it is the curve that is generated by the rotation of the trace point over the cam surface. As we give rotation to this cam, you could say that looks like you're already rotating this trace point. Assume that this trace point is going to rotate over the cam profile. This should give us the pitch curve. But physically or actually, this trace point is not rotating. The thing that is rotating is the cam itself, not the trace point. Make sense? So as this trace point is generated or rotates over the cam surface or cam profile, we're gonna end up with the pitch curve. And the key idea of this pitch curve, why it is important, because as I mentioned, when we try to expand this curve, this should give us the displacement diagram of the follower that was generated before. Now let us move to something else that we're gonna call the pressure angle. It is important to know what does it mean, the pressure angle. So simply the pressure angle, as already written here in the definition, it should be the angle between the direction of the follower motion and the normal to the pitch curve. So it is the angle, any angle, it should be between two different lines, right? So we have two lines here. One line is the direction that defines the direction of motion of the follower. The second line is the normal to the pitch curve. So what is the line of the direction of motion of the follower? Like this line. So this is the follower, the direction of motion of the follower just moving up or down over this vertical line in response to the rotation of the cam, right? So this blue line, this is the follower motion direction line. This is the line that defines the direction of the follower motion. And we need another line which should be the normal to the pitch curve. So where is the pitch curve? It should be the green curve. To find a normal to any curve, you have to find the tangent to that curve at this point first. And this is what we're gonna, at the trace point, we're just gonna draw a line. This line, it should be tangent, so it's gonna be horizontal in this way. Then you try to draw a normal over this tangent line at this point. This is gonna give us the normal to the pitch curve, which should be the red line as already shown here. As you can see that both lines, both of them, they already coincident, so the angle between them is gonna be 0. This is the pressure angle. So for this instant, at this instant of time, or at this angle of orientation of the cam profile or the cam itself, that the pressure angle is gonna be 0. But if we give rotation to the cam somehow in such a way that this trace point, it became this point, as you can see, I'm drawing here, there is another drawing of the follower, like it looks like the follower itself had been moved, but you should understand that the follower is not moving. The follower is just moving vertically in the reciprocating motion, right? But it won't gonna rotate. The thing that it should be rotating is the cam itself. So assuming that we give rotation to the cam in such a way that we're gonna have a shift between the normal to the cam profile, or in other words, to the normal of the green curve, which is the pitch curve, and the direction, the line of that describes the direction of motion of the follower. So this blue line, this is the direction of motion of the follower, and this red line, which should be normal to the tangent, this is the tangent to this curve, and this is the tangent line. If we draw a line that is normal to this tangent, we're gonna end up with this red line, which should define the normal to the pitch curve. We're gonna end up with an angle between them. This angle is gonna be the pressure angle that I'm talking about. So as you can see that as the cam rotates, this pressure angle is going to change. It's going to increase for a certain number of rotation or angle of rotation of the cam. Then after a while, it's going to decrease again. So this is what defines the pressure angle. Why this pressure angle is very important, and why we have the name as pressure, because this angle, it is somehow related to the pressure or the force that is going to impact or affect or acting on the follower itself. If we're gonna consider the force, but we weren't gonna do it, we would not are going to do it for this part of the cam design. We are skipping the force analysis for the cam design or for the cam mechanism. But if we considered, or we decided to consider the force analysis and the type of the force that should be acting between or generating between the cam, because as you can see at this instant, the cam tried to push in this direction, so there should be some force acting in this direction over the follower. This force, it would be significant, and the amount of this force definitely depends on the pressure angle. If this pressure angle is significant or large, this would result in some jamming in the reciprocating motion of the follower. The follower won't gonna able to slide through this slot or over its bearing. These are the bearings of the follower, so the follower should be moving up or down. So at any instant, of time, in case that this pressure angle is higher than a certain value, this certain value depends on the force generated. So we have to come up with this maximum pressure angle. We have to do force analysis to decide what is the maximum pressure angle that is allowed to us to give smooth reciprocating motion for the flow without any jamming. So that's why this pressure angle is kind of important in the design of the cam profile. So the main reason that this angle is very important, because if it is too large, a reciprocating follower would jam at its bearing, in case that would have very large a pressure angle, because in this case the radial force acting over the follower is going to be significant, and it would result in the jam of the follower, as we mentioned. Make sense? Another thing that we have to consider here is the pitch angle, or the pitch, the pitch point. The pitch point should be a point on the pressure curve. It is a point over the pressure curve. So again, what is the point that it should be located over the pressure curve? The pitch curve, is the trace point. We said that the trace point, this is the point that belongs to the pitch curve. This is the common point between the follower and the pitch curve. So the pitch point, it is different than the trace point. So the pitch point, it is also a point that belongs to the pitch curve, but we specially specify this point with the point that has the maximum pressure angle. As we said that the pressure angle changes from 0, then increase, then it's going to decrease again. So which point that belongs to the cam profile, or in other words, which point that belongs to the pitch curve, at which the pressure angle is going to be maximum, this is going to be the pitch point. And this pitch point, as I mentioned, it should be necessarily defined or important in case that we are interested in the force analysis and specifying what is the maximum pressure angle. So to define the maximum pressure angle, you have to define the pitch point that belongs to the cam first. So the pitch point is the point that belongs to the pitch curve that had the maximum pressure angle. Make sense? The next thing that we're going to discuss here is the base circle. The base circle is simply the smallest circle that can be drawn from the cam center of rotation, and it should be tangent to the physical cam profile. So going back here to the drawing, it should be the smallest circle that we can draw from the center of rotation of the cam, and it should be tangent to the cam profile, to the physical, to the actual cam profile. So the red thing, this is the cam profile, and this is the center of rotation of the cam. As you remember, when we start even introducing this type of the mechanism, of the cam mechanism, we said that this center of rotation, it should be shifted. It shouldn't be in the center of the disc itself, right? So anyway, the center of rotation, it will be defined if it is already known, and we try to draw a circle from or find the minimum circle with the minimum radius that would be drawn from this center point of rotation of the cam, and in the meanwhile it should be tangent to the cam profile. This is gonna give us the base circle that I'm talking about. So definitely, according to this definition, this circle that I'm tracing here, this circle, this is gonna be the base circle, which should be the smallest circle that can be generated from the center of the cam rotation, and in the meanwhile it should be tangent to the cam profile. So this circle here, it should be the base circle. This is the base circle. Make sense? So it is very important, and we're gonna use this circle to specify things during the design or the cam profile calculation or generation graphically. So it is, to be more precise, it should be named as generating the cam profile, because we are going to generate this thing graphically. Then we do have also another circle, which is the prime circle. This is like a virtual circle. It is not a physical circle like the base circle, but also it is the smallest circle that can be drawn from the cam center of rotation, very similar to the base circle, but it should be tangent to the pitch curve. So what is the difference between the base circle and the prime circle? The main difference that this one is tangent to the physical, the actual cam profile, but this one is tangent to the pitch curve. And as we said, as long as we are using a roller follower, there should be an offset between both curves, both profile, the cam profile and the pitch curve. And because of this shift, the prime circle will be different than the base circle. So the prime circle, which it should be this one, which it should be the angle from the center of rotation of the cam, and it should be the smallest circle that should be tangent to the pitch curve. As I am already tracing this circle, this is gonna be this green circle. This circle is gonna be the prime circle that I'm talking about. So as you can see, the prime circle and the base circle, both they are sharing the same center point, right? But there is an offset distance between them. This offset distance, as you can see, it should equal to the radius of the roller. So in case that we are using a roller follower, there should be a difference between the prime circle radius and the base circle radius. But if we are using a knife follower, there is no difference between them. And in this case, the prime circle and the base circle, they're gonna share the same circumference, or the same circle. They're gonna be typically the same circle with the same radius. So one of the things, so these are some things or some geometries that we have to consider or understand. We should distinguish between the pitch curve, the cam profile, the pitch circle, in addition to the prime circle. The pitch circle, this is just a circle that from the pitch point or any trace point at any instant of time of rotation of the cam itself. It is not crucial thing, but the crucial thing are these types of circle that we discussed, like the prime circle and the base circle. Remember that the objective is just to come up with this cam profile. So we had to fix these different types of geometries, and so we're gonna use them for the calculation, or in other words, the generation of the cam profile. So one of the things, as we discussed, there should be a difference between the base circle radius and the radius of the prime circle in case that we are using a roller follower. And this RR stands for the radius of RR, the roller's radius when using roller follower. But in case that we are using knife follower for knife followers, RR equals 0. There is no roller in this case, so it's simply you're gonna plug RR equals 0 into these expressions. So the base circle, which should be the minimum radius, and this minimum radius of the cam profile, and in many of the cases it will be given to us. Like you are required to come up with the suitable design or profile of the cam with a specific base circle or a specific minimum radius for a given displacement profile. So this R minimum will be given. This R minimum directly is going to be the radius of the base circle. We're going to need this value for some of the calculation during the generation of the cam profile. Also, we need the radius of the prime circle. This radius is going to be the radius of the prime circle, which is RP. It should equal to the RB plus RR. RR, this is the radius of the follower, the roller of the follower, as we discussed. And in case that we do have knife follower, so definitely it's going to be 0. And if RR equals 0, R prime, it will be R base. Both, they're going to be the same, indicating that the base circle and the prime circle will be the same circle as we discussed before. So the objective again is to come up with the cam profile, and to do so, to generate a cam profile, you should have some information or something should be provided to us, or at least you have to come up with these things before you start the generation of the cam profile. First of all, definitely we should have the follower displacement diagram. It should be either given, or if it is not given, you have to generate this displacement diagram first. Then also you should have the minimum radius of the cam, which is R minimum, because this R minimum is going to be the R base, which is going to be the base circle radius. In addition, the roller radius, it should be given to us, or in case that there is knife, it should be mentioned that there is knife follower. So in this case, RR is going to be 0. Then from this RR and R minimum, you're going to calculate the R prime, as we already discussed before. These data, we need them in order to generate the cam profile. In addition, you should be given the direction of rotation of the cam. It should be provided to us, as we are going to discuss through the next example. Make sense? So this is like introduction about the different geometries of the cam. And again, the objective is just to come up with the cam profile. What I'm going to do now, I'm just going to give you an example. Starting from the generation of the displacement diagram, I'm going to generate the displacement diagram. Then from the displacement diagram, I'm going to show you how we can come up with the cam profile for this displacement diagram. Make sense? Let us consider this example of the CAM mechanism that it is required to construct or graph the displacement diagram and the CAM profile. So it is required both. You have to generate first the displacement diagram, then you're gonna work over the graphing or drawing the CAM profile. For a plate cam mechanism or a disc cam mechanism, this is the type of the mechanism that we are going to consider through this part with reciprocating radial roller follower and all the time. So this is what we're assuming all the time for this part, as we discussed before, that we're gonna have plate cam mechanism or disc cam mechanism, which should be the same one, and with the reciprocating radial. It means that the follower is going to do reciprocating linear motion, and it is radial roller follower. It means that there is a roller. So this is going to be like the shape of the follower itself, how it looks like, right? There should be a roller, and the radius of the roller is going to be provided or given. The follower rises, then it's gonna start to describe the type of the motion, since we are going to generate the displacement diagram. So he should give us some information regarding the, the displacement or the description, written description of the displacement diagram of the follower too, so we can generate this diagram. So there is a little bit description in addition to some other information regarding to the prime circle. R prime is already given by 20 millimeter, and the follower, the radius of the follower, the roller of the follower, it is already given by 10 millimeter. So he describes here. So it is, since we are going to generate the displacement diagram of this follower, it is recommended that if you can come up with like a tentative plan how we can generate this displacement diagram. So you can put this plan either graphically, or you can just take some notes. So for example, initially he tells us that the follower is going to rise for 50 millimeter with a simple harmonic motion. So this is the first type of motion. This is the rise period. In 150 degrees of the cam rotation, this is gonna be theta. If you remember, like for any type of motion of the follower, as we discussed before, we should specify two things: the lift, which is L, that we used to refer to this lift as L, plus the theta, which is the angle, the part of the angle of the angles of rotations of the cam that would need it to achieve or execute this type of motion, which is the simple harmonic motion, as he already tells us here, that the follower is going to rise first. So this is the rise period. So we can say that this is, we said that generally we should have like three main events, right? We do have the rise, we do have dual, then we're gonna have the return. So the rise, it is going to rise with 50, so the lift is gonna be 50 millimeter. Then what? For theta, it's gonna be 150 degrees, and the type of motion is gonna be simple harmonic motion. Make sense? This is what he mentioned here. Then it's going to double for 30 degrees. So we do have double period, which is gonna be stationary follower. And this double, there is no need for the left because there is just horizontal line, but you should be given how much is theta for the double is gonna be 30 degrees. It's gonna be doubling for 30 degrees. Then it's going to return with also simple harmonic motion. It's going to return with simple harmonic motion in 150 degrees. So it's gonna be return. So this is gonna be the return. With lift, also the total L is gonna be the 50 millimeter because it's going to return the same lift, because he didn't break down the rise. He was going to rise 50 millimeter, then double, then it's gonna return again. Also definitely is gonna return the same period or the same distance that the follower had been raised. It will be returned again 50 millimeter, and the beta for this case is gonna be also 150 millimeter, and the type of motion is gonna be simple harmonic motion for the return period. It would be any other different type of motion. We discussed different types. We discussed the uniform velocity, we discussed the modified uniform velocity motion, the simple harmonic motion, the circular motion, in addition to the constant acceleration motion. So it would rise with type of motion, and it can return with any other type of motion. It is not necessary to rise and return with the same type of motion. It depends on the cam mechanism and the objective or the function or the way that we already going to implement or use this cam mechanism for. Another thing that you should consider here, if you try, so basically we do have like beta 1, this is for the first period, and beta 2 in addition to beta 3. These are 3 periods. If you sum these 3 betas, like 150 plus 30, this gives 180 plus 150, we're still missing 30 degrees. If you sum all of these 150 plus the 30, this is gonna give us 330 degrees of rotation of the cam. So how about if the other 30 degrees, there is still 30 degrees of rotation of the cam is missing. We have no clue, we have no idea. There is no information already given about this 30 degrees at the end. So automatically we're gonna consider that this 30 degrees is gonna be dual. So for beta 4 is gonna be 30 degrees. So this dual, it wasn't mentioned to us in this problem, but you should understand this point, because this is gonna start by rising is going to do lift for 50 millimeter with a certain type of motion. Then is going to dual for 30 degrees. Then it's gonna return with the same type of motion. Then what? We still have 30 degrees. Definitely we're gonna assume that this one is a dual displacement, like a shift between the first cycle and another new cycle. But if the sum of these 3 angles will 360 degrees, so there is no other dual, or there is no transition between the first cycle and the second cycle is going to consider. So I'm adding this dual here as a transition between the first cycle and the second cycle to fill into the gap. We do have a gap of 30 degrees, and this 30 degrees, there is no information were provided to us, unless he mentioned directly something regarding this 30 degree, so we have to stick to it. But in this case, he didn't give any kind of information regarding this 30 degree, so that's why I'm going to consider this is like kind of transition between the first cycle and second cycle. So I'm going to apply here a dual period between the first cycle and the second cycle. So this is like the written description of the plan. Even you can start, it is highly recommended to have an idea about the displacement diagram. Like what I'm gonna do here, I'm just gonna put a plan for this displacement, or have like a tentative shape of the displacement diagram that I should have here y, and then you're gonna have over the horizontal axis, it should be theta, as we used to represent the displacement diagram. And this displacement diagram is going to be broken down into 4 periods. Like this is period 1, and there is another period, and third and fourth, right? So I'm gonna break it down into 4 periods. So you could consider like this is the entire period of the cam rotation at 30 degrees of the cam rotation. And in the first period, we're gonna have rise, as he mentioned. So this is the rise period. And the type of motion, it should be simple harmonic motion. Then your objective is just to apply the procedure that we explained before in the previous video regarding the generation of simple harmonic motion. Then we're gonna have dual for 30 degrees. So this is gonna be the dual, and you should specify the beta. So this beta here, it should be 150. This is gonna be beta 1. It is just 150 degrees, 150 degrees. And this lift, total lift, is already given to us by 50 millimeter. Make sense? And we're gonna have here for another, this is gonna be beta 2, it's just 30 degrees. Then we're gonna have the return. This is gonna be the return for only 150 degrees. For 150 degrees, beta 3 is gonna be 150 degrees. And definitely we're gonna have the dual for 30 degrees. This is gonna be the beta 4, right? And this is gonna be the return. And we should have here another dual period. Make sense? And the return type of motion is simple harmonic motion as well. So this is like a tentative shape of the displacement diagram, and the objective now is just to generate this displacement diagram graphically. Then from the displacement diagram, we're gonna start generating the cam profile. Make sense? And this is what we are going to do. Alright, so I'm gonna start with the displacement diagram as already described up there. We said that in the rise period we should have simple harmonic motion, then we're gonna have dual period for 30 degrees, then we're gonna have the return period also for 150 degrees as simple harmonic motion, then we're gonna have dual for 30 degrees at the end of the cam cycle or the cam rotation. Make sense? So, and you should prepare like a portrait, landscape. You should work on the landscape orientation of the A4 drawing sheet. This is what it is recommended, because we should have the displacement, both the displacement diagram and the cam profile, both of them, they should be located within the same drawing sheet, within the same drawing area. So because definitely the cam profile, it will be extracted from the displacement diagram, so they should be located to the same drawing sheet. So make sure that when you start drawing the displacement diagram, that you work or give orientation to the A4 drawing sheet to be landscaped. So this is gonna fit it. So you're gonna make sure that the displacement diagram, the same thing, the cam profile, both they're gonna fit to the same drawing sheet as I'm gonna show you. So, and this is what we're gonna assume, that consider like this is our main frame of the A4, but it is oriented in the landscape direction as I just mentioned, right? So basically we're gonna start here with generating the displacement diagram. And to draw the displacement diagram and give room and space for the cam profile to be drawn, it is recommended to draw or try to generate the displacement diagram on the right upper corner of the A4 landscaped drawing sheet. Like in the landscape direction, pick the right upper corner and start to generate. So I'm gonna start to draw the displacement diagram within this upper corner as I'm gonna show you. So we're gonna start first by drawing the theta and y axes. You have definitely to use your tools. The tool that you're going to use in the arrow triangle, in addition to the camps, in addition to the pencils, as we discussed, and even as we used to use them for the graphical solution of the kinematic analysis of different mechanisms. So this is for the theta axis. Then I'm gonna draw the y axis as already given here. In this case, this is gonna be the y axis. So this is y and this is the theta. Make sense? Then your objective is just to measure over this theta axis, is just to measure 12 centimeters. Why 12 centimeters? Because we said that, as we discussed the previous meeting, the camera should be rotating 360 degrees as angle of rotation, right? And if we assume the scale for this angle, like every 30 degrees of the cam rotation is equivalent to 1 centimeter of the drawing scale. So in this case, if you divide 360 divided by 30, this is gonna give us 12 centimeters. And this is what we're gonna do. Your objective is just to measure. Don't break it down into centimeters. Just measure initially. Just measure 12 centimeters and mark a point from the 0 to the 12 centimeter distance. Just measure 12 centimeters over the theta axis, and once you measure this distance, just mark a point. So this is like, it's gonna be the 12 centimeter distance. Make sense? So this is gonna be the 12. Then what? Your objective is just to draw a complete or close like a rectangular dash line. You're just gonna draw a rectangular dash line in this way. Then there is, so this is gonna be the rectangular, the height of this rectangular dash line, it should be the total lift. The total lift is already given to us by 50 millimeters. So if we decided to work like the 50 scale 1 to 1, so the 50 millimeter, it should equivalent to the 5 centimeter. So I'm gonna measure over the y-axis 5 millimeter, and then I'm gonna mark a point. Then your objective is just to measure over the y-axis the total lift, which is already given to us by 50 millimeter, which is equivalent to 5 centimeter. I'm gonna work at a scale 1 to 1, so I'm gonna measure the 5 centimeter, then I'm gonna mark a point. Then from this point, I'm just gonna draw a horizontal line to close the dashed rectangular shape, as already shown here. Make sense? So you could consider that this is the drawing area, this is the drawing zone. You have to represent all the rise, the dowel, the return, and the other dowel, the 4 periods of the cam as already or the follower displacement as already described or given to us on the description up there for the given problem. It should be represented within this dash line. But you have to break it down into 4 periods. We have 4 periods, we have 4 periods, right? In the first period, which is 150, we have to do rise with simple harmonic motion. So you have to measure the 150 over the theta axis. The 150, if you divide 150 by 30 degrees, this is gonna give us 5. It means that your objective is just to measure 5 centimeter. Remember that every 30 degrees is equivalent to 1 centimeter into our scale. So it means that I'm just gonna measure over the theta axis 5 centimeters, and starting from the 0 point, measure 5 centimeters, we're gonna end up with this point here. So this is gonna be the 5 centimeter point. Then from this point, you're just gonna draw another dash line going up, vertical line from the top here, going down to this mark. So this is gonna give us the first period. The first period should be the simple harmonic motion period. Make sense? Then how about the second period? The second period should be dowel. The dowel just for 30 degrees, it means just 1 centimeter. So you're just gonna measure 1 centimeter and mark a point. Then from this point, you're gonna start to draw a vertical line to define the second period as well. So I'm gonna draw this vertical line in this way to define the second period. Make sure that it is perfectly vertical. And do the same for the return period, which is also 150 degrees. So if you divided 150 by 30, this is gonna give us 5 centimeters. So or 5, which should be equivalent to 5 centimeters. So you're just gonna measure another 5 centimeters over, starting from this point, measure 5 centimeters in this direction. You're gonna end up with a point here. So this is gonna be the 5 centimeter. Then you're just gonna draw another vertical line from this point to define the return period. Make sense? So these are the 4 periods that we already discussing here. We have the dowel, we have the return, we have another dowel in the middle, and we have the rise for 5 centimeters, rise and 5 centimeter as beta direction. So this is like beta 1, beta 2, beta 3, beta 4 as we already discussed up there. Make sense? Then your objective is just to start generating the first type of motion, which is the simple harmonic motion within the rise period. Following the same procedure that we explained over the previous video of generating the simple harmonic motion. So what was the first step? The first step is just to draw a circle, and the radius of this circle, it should equal to the L over 2. What is L? It should be the total height. The total height, it is 5 centimeters. So your objective is just to measure 2.5 centimeters, which is 25 millimeters. And from this midpoint, you have to locate the midpoint of this total height. Of this height from this point to this point, where is the midpoint? You have to locate this midpoint. Make sense? First, so I'm just gonna use a different color here. So from this midpoint, your objective is just to locate the midpoint. Just measure from down here 2 centimeters, 2.5 centimeters. Then you're gonna use the compass to draw a circle. So fix with the middle tip here, then you're gonna touch with the lead tip at either this point or this point. Then you're just gonna draw a circle. Make sure that the circular is perfect circle, not like this, because I'm just using my hand since I'm using other tools for this video. But you have to make sure that this circle, it should be a perfect circle as much as you can. Definitely you have to use the compass to be accurate. Then what you're gonna do, you're gonna break it down as we discussed for the simple harmonic motion into 4 sectors. And if you divided 180 by 6, this is gonna give us the 30 degrees angle. So your objective is just to use the protractor that already traced over the Aristo triangle or a separate protractor, it doesn't matter, and measure an angle from this vertical line from this center point. Measure the angle starting from this line going all this direction, you're gonna end up with a 30 degrees. So your objective is just to measure from this point and draw a very light line. This line, it should be 30 degrees. this angle, it should be the 30 degrees that I'm talking about. Then what? You're just gonna measure another 30 degrees, one more 30 degrees to draw this second line. To draw this second line here. Make sense? Then you're gonna end up with some point. This is gonna give us point 1, and there is another point here that these are the point of intersection of the circle to these lines. If you can simply draw a line, vertical line, going up vertical, you're gonna intersect with the circle at the other side. In this way, in another point, and the same thing starting from this point, you're just gonna go up vertical. This is going to intersect with the circle in another point. And definitely if you draw a horizontal line from this center point, draw a horizontal line from this center point, this is gonna give us another point, which it should be this one. So we have located some points here. This is gonna be point and another point of intersection. All of these points of intersection, definitely in addition to these 2 points, you have to mark these points. Then you're gonna give them numbers starting from 0. Why this is gonna be the 0? Because this is our start point. We're gonna start from here and go up. We're gonna rise starting from this point. So this is the start point, this is the 0 point. Definitely this is gonna be point 1, this is gonna be point 2, point 3 and 4, 5 and 6. Following the same procedure that we explained over the previous video regarding the generation of the simple harmonic motion. Then what? Your objective is just to break down the beta or the theta axis for the simple harmonic for the rise period 6 digits, as we did for the 6 sectors. For this semicircle, we have to divide 6 digits also over this one. But remember that how much is the length of this period? It is 5 centimeters. So your objective is just to divide 5 centimeter divided by 6. This is gonna give us 0.0. This is gonna give us exactly 0.833 and lots of 3's. So it means that it is very acceptable if you just gonna assume that, try to give it like 0.30 centimeter, which it should be like 8 millimeter, 0.3 millimeter. So it means that your objective is just to break it down. Every digit is gonna be approximately 8.5, or you're just gonna mark a point just beyond the 8 millimeter mark or dash on the ruler or the triangle, the Aristotle triangle. So your objective is just to break it down into like around 8.3 millimeter each. So, and this is what we're gonna do. I'm just gonna measure here, starting from the 0 point. I'm gonna use the let us use the same color here, like this one, so, or red color. So starting from this point, I'm just gonna measure 8 millimeter and try to have it like 8 millimeter and something. So we're gonna end up with this first mark, then we're gonna have another mark here, and a third mark, fourth, fifth, and the sixth, right? So this is like 0. We're gonna start marking also from 0. This is gonna be the first mark, the second, the third, the fourth, 5 and 6. So these are the 6 marks. Then what you're gonna do, you're just gonna draw vertical lines. You're gonna start drawing vertical lines from these marks in this way, going up, and no, it should from this mark. You're just gonna draw a vertical line in this way, and from this mark another vertical line. From this one, I'm not drawing anything, okay. So vertical line, and from this mark another vertical line, and so on. And definitely the last one, it should be considered to the vertical line here, which it should be this one. Make sense? Then what your objective is just to draw horizontal line from these marks over the circle. You're just gonna draw horizontal lines starting from even the one on the top here, the sixth, starting from this line, and we're gonna have here from the 5 we're gonna have another line, and from the 4 we're gonna have a line, and and the 3, we just gonna continue this line, and the 2, the 3, the 1, and the 0 definitely is gonna be this line. Make sense? Which is just the last line. Then your objective is just to mark some points, to locate some points. Point of intersection of line 0 with 0 should be definitely, this is gonna be the first point. Then line 1 with line 1 is going to intersect in a point. Line 2 with line 2 is going to intersect in a point. 3 with 3 in a point. And 4 with 4 in a point. Then we do have the 5 with the 5 is gonna be intersect in a point. And the 6 with the 6 is going to intersect in a point. Then your objective is just to connect these points together with a curve. So I'm just gonna connect these points together by hand. You just guys gonna try to connect them and to take it easy as I'm doing as much as you can. This way. This is gonna give us, I'm sorry, it should be like this is up to this point, right? So this is gonna give us the first curve, the first simple harmonic motion. It's gonna be this curve as already we got it here. Make sense? Then we, after this simple harmonic motion, we should have here a dowel period. So there should be a line here, a horizontal line representing the dowel period. Now let us work over the return period, but try to be smart kind of, because you can do the same procedure as we did it for the rise. You can apply the same procedure for the simple harmonic motion within for the return period, as we even discussed in the previous video. Like you're gonna generate the semicircle over the right side here. You're gonna break it down. You're just gonna divide it into 6 sectors and draw horizontal line, break it down into 5 digits, or then you're gonna draw the vertical lines, locate the center point, the point of intersection. Just repeat the procedure that we did for the simple harmonic motion generation during the rise period. You're gonna repeat it again for the return period. You can do it, right? But try to be smart. And since we do have the simple harmonic motion, here it is already distributed over 50 millimeter left and 150 degrees over the cam rotation, and we do have the same type of motion over the same periods. We do have the same 150 degrees of the cam, and we do have the 50 millimeter of left. It means that we can make use of this circle to generate even, and we can use the same circle for generating the simple harmonic motion for the second return period. And instead of redrawing again another semicircle, break it down into 6 digits or sectors, you can make use of this circle and use it for the other return period, as long as we have the same type of motion with the same specification, 150 and 50 left, right? And this is what I'm gonna do. So again, that this period, it should be 150 degrees. So if you divide 150 divided by 30 degrees, this is gonna give us the 5, which indicate like 30 degrees, or 5 angles of 30 degrees. Each one, it will be 1 centimeter. It means that this should be 5 centimeter. Then you're gonna break it down, the 5 centimeter, into 6 digits as we did for this one. It means that every digit will be 8.3 millimeter. So your objective is just to measure, starting from this is gonna be this is not the 0 point, but you could consider that this is the start point. Because if you remember that in the return period, we usually start numbering from this point on the top. So this is gonna be our start point, our 0 point. Let me use another pencil or pen here. So starting from this 0 point, this is gonna be the 0 point. Then you're gonna go all the way in this direction. Then you're just gonna measure 8.3 millimeter and mark a point. So I'm gonna measure 8.3 millimeters, and then I'm going to mark a point. So this is gonna give us the first mark, and this is gonna give us the second mark, the third, the fourth, and the fifth. And definitely this is gonna be number 6. Then you're just gonna draw vertical lines from these points. You're just gonna draw a vertical line going down, and make sure that it is completely vertical this way. And from this point, draw a vertical line, and so on. And definitely this is gonna be the last line. Then your objective is just to make, as I mentioned, just this is gonna be, by the way, this is 1 and 2 and 3 and 4, 5 and number 6, right? And you should have we can make use of these lines because it should be going down here. But we have to do rearrangement again to this numbering. So we're gonna start from, this is gonna be like, we're gonna, instead of having this 0, this is gonna be the 0, I'm sorry, instead of having this 6 is gonna be, this is 0, and this is gonna be 1, and this is gonna be 2, sorry, this is gonna be the 2, and the 3 is gonna be this same 3, and 4, 5, and number 6, right? So then you just gonna draw horizontal lines, continue these horizontal lines, just extend these lines. I'm just gonna extend this line number 5, which now it became line 1, that it should be intersecting with line 1. Okay, so I'm just gonna extend this line horizontal in this way, and I'm gonna do the same for the other lines. Okay, so I already got these different lines, so we now we can locate the intersections. So the 0 will be definitely, this is one of the points. Then we're gonna have the 1 with the 1 line, both they're gonna intersect in a point. Then we're gonna have another point for 2, another point for the 3, another point for 4 and 5 and 6. Then your objective is just to connect these points by hand as we did previously for the previous case. So we're just gonna connect them by hand to end up with the simple harmonic motion in the written period. In this way. Make sense? So this is the rise, the displacement diagram in the rise period. Then we're gonna have dual for 30 degrees, then we're gonna have return, then we're gonna have another dual at the end for another 30 degree. So this is for the displacement diagram, how we can generate this one graphically. Make sense? Then from this displacement diagram, we're gonna start to work over the cam profile. Now let us move to the cam profile. And so once we finish the displacement diagram, we can work directly on the cam profile. And to do so, the first step actually is to try to break down in this displacement diagram into equal digits or divisions or parts. And the length of each part is going to be like 1 centimeter, as long as we're already assuming 1 centimeter refers to 30 degrees of the cam rotation. So the objective is just to break it down into 1 centimeters. It's going to be like 12 centimeters at the end, like 12 digits. So, and this is what we're going to do. So simply to do it, because it is kind of crowded here, we do have lots of numbers and lots of lines. So make sure that you don't be confused with the so many lines that you're going to draw. So one of the things basically is to try to just extend this line down, this vertical line that already shown here, just move it down a little bit here. Then you're just gonna draw another horizontal line that is parallel to the theta axis, and you're gonna divide over this line, because the original theta line, it is already crowded, as I mentioned, with so many things. So then you're just gonna measure 1 centimeter starting from, this is gonna be the 0 point, right? This is gonna be the first point, which is just gonna be the 0. Then you're just gonna start to mark other points. So this is gonna be like point, this is mark 1, mark 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and the 12, right? Then you're just gonna give them numbers. This is gonna be like 1, and this is gonna be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the 12. Make sense? So this is the first step. Remember that we just started the generating the cam profile. So this is the first step, is just to draw this line that is parallel to the theta line. Why I'm drawing this one with offset distance from the original theta line? Because the theta line is going to be definitely crowded with so many divisions. So don't be confused between this one and this one mark. This one mark we measured this one over 8.3 millimeters. But this one, it should be over 10 millimeters. So this one mark is different than this one. This two mark is different than this one, and so on. So that's why it is recommended to draw another line that is parallel to the original theta and divide over this line. Then what you're going to do, you're going to draw another line that is also parallel to the y line, but it is kind of offset from this vertical line, y-axis. This is the vertical y-axis. I'm going to draw another line here, and make sure that this offset distance, it should be kind of a little bit large distance, bigger definitely than this one, because this vertical line, you're just going to draw another vertical line here that is completely parallel to this line with any offset distance. There is no specific way of specifying this offset distance between this vertical line and the new one that I'm going to draw, but make sure that it is kind of large, and you're gonna draw the first vertical line. This is gonna be the first axis over which the center point of rotation of the cam is going to be located, as long as we're already working as the follower is line follower, inline follower, and this is the type of the mechanism that we are going to consider. A line follower, it means that the follower motion is going to be directly considered, or the axis of the follower motion is going to be considered vertically to the center of the cam rotation, as I'm going to show you. So what I'm going to do, I'm just going to draw another line, vertical line. You can use the arrow triangle to draw this vertical line with an offset distance in this way. This definitely is going to give us the center point, or the center axis of the cam, and the center of rotation of the cam, it should be located somewhere over this line. Make sense? So this is the second step. So the first step is just to draw this horizontal line and break it into 12 centimeters, and this vertical line. Then what? Your objective is just to start to draw vertical lines from every one of these marks over the new horizontal line. You're just gonna go up, intersect with the displacement diagram, then you're gonna go horizontal and put a mark here next to this mark 1. So like what I'm gonna do here for mark 1, I'm just gonna draw a vertical line till I intersect with this curve, with the displacement curve. Then from this point of intersection, I'm just gonna draw a horizontal line going all the way till I hit again the vertical line on the left, in this way. Make sense? Then we're gonna end up with intersection point. This intersection point, I'm just gonna mark this point and give it number like 1, like 0.1. Make sense? So this is, and repeat the same for the other lines, and this is what we're gonna do. So I'm just gonna use here a different color just to, so we can see the marks. So this is gonna be the mark 1. And let us initially start with putting the mark number on the right. Then once we move up there, we're gonna switch putting the numbers on the left. So because we're gonna have like 12 numbers, right? So we have to put number for each one of these marks. So repeat again for the second mark, for mark 2. I'm gonna go up, intersect with the curve at a point. Then from this point, you're just gonna draw a horizontal line going all the way till you hit to this vertical line. This is gonna give us another mark. So this is gonna be mark 2. Make sense? And so on. So this is gonna give us the mark 3. This is mark 3. And for 4, just pick another color. Go up, intersect with the curve, then move horizontal. You're gonna end up with another mark here. So this is gonna be mark 4. And repeat again. If we're gonna go up with the 5, it is, by the way, it is not necessary that all the time you draw a vertical line. If you can just put the ruler or the triangle and mark a point and try to draw another, like you gonna draw a horizontal line this way, then you're gonna locate another mark. So this is gonna be the 5th mark in this way. Make sense? Then for the 6th mark, as you can see, if we draw a vertical line, it's gonna be conceded to this line. It's gonna be conceded to this line. Then from this point, I'm gonna draw another line going horizontal. So we're gonna end up with the same mark. So I'm gonna put the 6th mark on the other side, because these two this mark is it is a common between the 6 and the 5 point, right? Repeat again for the 7. From the 7, you're just gonna draw a vertical line, intersect with the curve. Then from this point, you're just gonna go horizontal all the way till you're gonna find here the 7th. In this way. And definitely the 7th, if your drawing is accurate, it should be the same, sharing the same mark with the 4. The same thing, if you try to work over the 8 and intersect with the curve, the 8 and intersect with the curve and go all the way, you're gonna find that the 8 also sharing the same mark with the 3. This is just because of the symmetry, because this is the rise period. It is typically identical to the return period in terms of beta and even the left. So that's why these two marks, or every mark will be common between different, like different marks. Like this is gonna be the second, the mark 2, and this is mark 9. And for mark 10, if you're just gonna go up, this is the mark 10 here. And let us try to draw a vertical line. It's going to intersect. Then from this point of intersection, we just gonna draw a horizontal line or locate a mark up there. So this mark will be somehow also considered to the mark number 1. Okay, so it will be considered with 1 here. So this is gonna be the 10th. And the 11th and the 12th, both they're gonna be considered with the 0, because there should be, if we draw a horizontal line here, this is the first horizontal line actually that we should draw from the 0 point going all the way. So this is gonna give us the 0, and the 11 and the 12 points will be also considered to the 0. So this mark, it had 3 things: 0 and the 11 and the 12. Make sense? So locate these points, and this is going to be the 3rd step. So the first step, just to draw the line, break it down into 12 digits, 1 centimeters. Then you're going to draw another vertical line offset from the main vertical line y-axis, completely parallel to it, but offset within any distance. And then you're just going to go up. This is the 3rd step. You just go up from every one of these marks, intersect with the displacement curve, and move horizontal till you're going to put a mark over the vertical axis. Then what? Your objective, the next step, is just from the 0 point, from this 0 point, you're just gonna measure. You're just gonna measure the R prime. What is the R prime? This is the radius of the prime circle, which already given to us on the top by 20 millimeter. So your objective here is just R prime was given to us by 20 millimeter. And your objective also is to calculate the R base, the radius of the base circle. We said that the radius of the base circle, it should be R minimum, the minimum radius of the cam. But he didn't give us a minimum radius of the cam. And instead, he gave us the prime circle by 20 millimeter. So how much is the base circle? The base circle, according to the definition of the primary and base circle that we discussed before, it should equal to the prime circle negative the radius of the roller of the follower, which is already given by 10 millimeter. So this is gonna give us the 20 negative 10. This is gonna give us the base circle with a radius as 10 millimeter. So we're gonna need these two numbers, starting with the prime circle. Your objective here is just to locate the center of the cam rotation. This center of the cam rotation, starting from the 0 point, you're just gonna measure the R prime. This is gonna be the 4th step. It's just from the 0 point, measure the R prime, which is already given by 20 millimeter, to locate the center point. So measuring 20 millimeter from this 0 going down, you're gonna locate the center point of rotation of the cam. And you can even just put here something that refers that this is the center point of rotation of the cam. Make sense? Then what, you're gonna draw a circle, this circle with a radius equal to the base circle. So your objective, or the base circle radius, your objective is just to draw the base circle with R equal to 10 millimeters. So you're gonna use the cams fixing from this point. You're gonna put the metal tip here and draw a circle which should be the base circle in this case. Make sense? So I'm just gonna try to draw this base circle. I'm gonna try to be accurate as much as I can since I'm using my free hand, but definitely you have to use you're gonna use the cams for this circle. Make sense? So this is gonna give us the base circle. Then what, your objective is just to break it down. You're gonna break this circle into 12 sectors. So if you divide 360 degrees of rotation divided by 12, this is gonna give us 30 degrees. So your objective is just to measure, starting from the vertical axis, 30 degrees to the right and draw a line, then another 30 degrees and draw a line, another 30 degrees and draw a line, and so on. So you're gonna end up with the 12 sectors. And this is what we're gonna do. So your objective is just to break it down into 12 sectors, this circle in this way. So you're gonna use the protractor starting from the vertical line, and then from the center point, you're just gonna measure an angle of 30 degrees to draw this line. And make sure that you try to have this line long as much as you can, very long line in this way, passing over the center point or the center of rotation of the cam, in such a way that this angle, it should be 30 degrees. Then you're gonna measure another 30 degrees this direction, this way. You're gonna measure another 30 degrees and draw another line from this 0 point or center point in this way. And so on. Measure another 30 degrees. If you measure another 30 degrees, this definitely is gonna give us the horizontal line. So we're gonna have here this horizontal line in this way. Then measure another 30 degrees from this direction to end up with another line in this way. And so on. Repeat. From the center point, measure and draw the line. And definitely we're going to have this at the vertical line is one of the lines. This vertical line. So we already got here all the 12 sectors. If you just count here, starting from this line, this is going to be the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, returning back again to the 12. So these are the 12 sectors that we're already dividing. As you can see, try to draw these lines are long lines as much as you can, because we're gonna use them for some intersections here. So the next step is just to give number to each one of these lines. Starting from this one is gonna be the 0 line. This is gonna be the 0 line, and then we're gonna go all the way either this direction or the opposite direction to return again to the 12. So definitely this vertical line, it should be the 12 and the line number 0, right? So, but which direction that we're gonna give number? So for example, we can start, as I mentioned, from either like putting 0, then 1, 2, 3, and so on, go all the way this direction. This is the clockwise direction. Or we can go counterclockwise direction in the number. So basically, you're gonna number these lines in a direction that is opposite to the cam rotation direction that is already given to us in the problem. So again, the direction of numbering these lines, it should be opposite to the cam rotation as already given in the problem. But in this problem, he didn't mention anything regarding the cam rotation direction. He didn't mention whatever it rotates, clockwise or counterclockwise direction. So if the cam rotation it is not given, we can assume that it rotates in the clockwise direction, assume that it rotates in the clockwise direction. You can even assume that it rotates in the opposite direction, but let us fix this direction of assumption through this course. Like if the cam direction rotate, the direction of the cam rotation is not given, assume that it rotates in the clockwise direction, and in this case you're gonna do the numbering in the counterclockwise direction. Make sense? Counterclockwise direction, it means that this is gonna be 0, this is gonna be 1 and 2 and so on. So this is gonna be the 0. Then we're gonna have the line number 1. This is line 2, line 3, and line 4, and line 5, 6, 7, 8, and 9, 10, which it should be this line, and 11, and we're gonna return back again as I mentioned for the 12. So all the number these lines, put number to this line in a direction that is opposite to the direction of the cam rotation. If the cam rotation is not given, assume that it is already given in the clockwise direction and put the numbering in the counterclockwise direction. Make sense? Then what? You're gonna use the cams and fix with the middle tip here. You're gonna use the cams and then you're gonna fix with the metal tip here and touch with the lead tip at each one of these marks and give it rotation till you hit the corresponding mark or the corresponding line number. So for example, we're gonna starting with the 0 or skip the 0. Let us start with the mark number 1. Mark 1. You're gonna fix with the metal tip here. Then what? You're gonna touch with the lead tip at this point and you're gonna give rotation till you hit line 1. So we're gonna give rotation in this direction till I'm gonna put a mark here on line 1. So this is gonna give me 1 point. Do the same from the same center of rotation of the cam, put the metal tip here and touch with the lead tip. Then you're gonna give rotation till you're gonna hit with the cams till you're gonna touch the other line, the line number 2. Since this is mark 2, you're gonna end up with another point. And repeat and so on for the other points, starting even from the 0. So if you try to fix with the metal tip here and touch with the lead tip and start to rotate to hit the 0, you're already over the 0. So this is definitely gonna give us one of the points. So your objective is just to locate some points over the graph, as I'm doing here. Make sense? And this is what we're gonna do. So your objective is just to locate some points. So this is definitely is gonna be one of the points. This is gonna be the second point and the third point and so on and repeat. So fixing from this point and touching at the 3 and rotate all the way till you're gonna hit line number 3 in a point. This is gonna give us another point and so on. Repeat for the others. So we're gonna end up with some points, like for example line 8. So for mark 8, you're gonna fix here, and instead of going this direction, you can just rotate the cams this direction just to locate a point. You're just gonna rotate all the way this direction till you're gonna hit a point over line 8. Make sense? So your objective is just to locate some points starting from the 0 point. Then we're gonna have point 1. This is gonna be like point 2 and point 3 and point 4 and so on. Make sense? Once you mark these points are the trace points that we already defined. And this trace point, this is what define the pitch curve as we discussed before. Even if the pitch curve is required, for example, he may ask us to find or to locate the pitch curve. So your objective is just to connect these points by hand to define the pitch curve. And this is what we're gonna do. If you just connect these points by hand this way, you shall end up with the pitch curve. Just I'm drawing this curve as dashed just to distinguish this curve from the original curve of the cam profile that we supposed to. So this dash curve, this represents the cam, the pitch curve of the cam itself. Make sense? Now, since we're already using a roller follower, your objective is just to draw a circle from these pitch centers, pitch points, and the radius of this circle, it should equal to the RR, which is the radius of the roller that is already given by 10 millimeters. So what you're gonna do, you're gonna fix with the metal tip here and draw a circle. This is gonna give us the first roller, and repeat for the other centers. You're gonna draw lots of circles here. Like this, at this center point, I'm just gonna draw a circle. This is gonna give us the roller circle. Definitely you have to use the cams to be more accurate. Don't use your hand as I'm doing here. So also you're gonna draw a circle in this way at this point, and another circle at this point, and so on. You keep repeating for all the points from all the center or the pitch circles. You're gonna end up with lots of circles as I'm generating now. Again, you have to use the cams to be more accurate in generating these circles. Then we almost done your objective. The last step is just to connect the tangencies of all of these circles together by hand to end up with the cam profile. You're just gonna use your hand for connecting these tangencies to end up with the cam profile graphically, and this is gonna be it for this problem. Something that you should understand, do you see this circle in the middle here and this circle, this base circle? They should be tangent to each other. As long as our drawing is accurate, they should be tangent. Why? This is the base circle with the minimum or the smallest radius that we have for this cam profile. So these two circles, they should be tangent. If you already accurately using the tools, we're gonna end up with tangency between these two circles. Make sense? Then the last step, as I mentioned, is just to try to connect by hand the tangencies of these circles to end up with the cam profile. And this is what I'm gonna do. So try to draw like a line or like a curve that is tangent internally to all of these circles of the rollers. Try to be accurate as much as you can to end up with this curve. This definitely is gonna give us the cam profile that we already seeking in this way. And for these tangencies, you're just gonna use freehand sketching. So this brown thing, this definitely what is already inside, this is gonna be the cam profile. This thing is gonna be the cam profile as required. This is the cam profile which is already required, but this circle, this is gonna be the pitch curve. This is gonna be the pitch curve. If it is required, you can connect these points together, and these are the different rollers, and the follower it should be somewhere here moving up and down, right? So this is for this problem, and this is how we can create or come up with the cam profile for a given displacement. We started from the displacement diagram. I showed you how we can completely generate this graph for the displacement diagram, moving to the cam profile till we end up with the cam profile as already required. And remember that for this type of problem, we do have the follower is in line with the cam. It means that the line of action of moving the follower is gonna move up and down over this vertical line that already passing through the center point of rotation of the cam. And this thing in the middle, this is gonna be the cam. Then once this cam rotates, it should generate or provide a motion to the follower that can be described by this displacement diagram as we did here. Make sense? So this is for the cam profile, how we can generate, and this is generally for the cam mechanism. And that's it, nothing else that I can add to this part. So your objective is just to try to practice these things by hand, and that's it for the cam mechanism, and that's it for this video. And thank you, and see you in another video.